Good morning, everyone. This is Monday, March 23rd, AP Statistics. And we're going to start off today with just a quick explanation. I did post answers to the previous homework assignment. I hope that you did look at it so that there's no issues or questions. Please note that you can always email me directly at htucker@sheltonpublicschools.org, or you can make comments to the video thread if you want, or I believe there's a way in the classroom where you could just post a stream. And I'm going to look into that more as we go so we don't clutter the classroom assignments page with comments. All right. Also, please make sure you log in one time a day. Some of you guys still hitting that login button multiple times, so I see your name multiple times. Just once a day is fine. Thank you very much. Now, let's talk about a quick review of our two proportion Z test and confidence interval for the same. So we're going to start off with a new example. We take a simple random sample of 80 people from Connecticut, and we find 52 of them are making at least $85,000 a year. Similarly, we sample from New York 75 people. We find 55 of them are also making at least $85,000 or more a year. So the question is twofold. Number one, let's pick a confidence interval at the 95% level for where we think the true difference between the states will fall. And then we're going to follow it up with the two sample proportion Z test for pretty much the same question. Is there a significant difference between the two states? Let's summarize the data so far. Okay, so I have Connecticut and I have New York. And what I'm going to do is make my table. I have N, X, P hat, Q hat. That's going to do it for the data portion. Then there's going to be our conditions, the SRS, the 10% rule, and whether we have at least 10 for NP and NQ. All right, so I told you that we had 80 people in Connecticut, and of them, 52 made at least $85,000 a year or more. And similarly in New York, we had 75 people and 55 of them were making good money. Well, what is P hat for Connecticut? 52 divided by 80 is 0.65, leaving 0.35 for Q hat. And in New York, 55 over 75 is 0.73 repeating, which leaves 0.2667 for the Q hat. So far, so good. All we've done is summarized our data. Now the conditions. Well, were they SRSs from both samples? I did say an SRS was taken. So we'll say given for both, because it was. 10% rule. Are there at least 800 people in Connecticut that could make money? Well, yeah, there are, even given the current state quarantine. Are there at least 750 in New York? Again, yes, there sure are. Now, the NP and the NQ hats, we got 52 and Connecticut and 55 in New York. Now, in Connecticut, that left 28 for the NQ hat, and in New York, 20. Those are all at least 10. So far, so good? All right. Now, we know we have to do two things, the confidence interval as well as the hypothesis test. Since we know we need a P hat combined for the hypothesis test, I'm just going to do that now since we're in that mode. So what is my P hat combined? Well, I said it was the sum of the X's, so 52 and 55, over the sum of the N's, 80 and 75. If you add them up and divide, you get 0.6903, leaving Q hat combined as 0.3097. We got everything going on. We're good so far? All right. While I'm here, I also know that I need hypotheses, so I'll put my null and my alternate. Now, again, we're looking to see whether or not the two states have a mean difference between them. Okay, let's say a proportional difference. So the null is that the P difference is 0, as usual. And again, this is only going to be when there's no difference expected. If I said I expected a 10% difference, that would be 0.10. But I didn't. I said, is there any difference at all? And that also helps me figure out my alternate. It is that the p-diff does not equal 0. I don't know if one's better than the other, and I wouldn't know until I took the data and analyzed it. So I'm just going to test to see if there's any difference, which again means this is a two-tail test. I'm going to find the area in one tail, and I'm going to double it to find the p-value. Okay, I think I've got all the stuff I need on the board. Now I have to find, well, let's see, what do I want to do first? I said confidence first. Let's just do the confidence first. So I'm going to put it up here. I'm going to jump out of the screen for a second. How do we find confidence intervals? Well, it is the difference in the p-hats. So 0.65 minus 0.73 repeating, plus or minus the critical z. Now, what's critical z for our confidence interval at 95%? I should also add those details. I said alpha was 5%. And I want a 95% confidence interval. So the critical z for 95% is 1.96. Am I going to have enough room over here for my equation? Probably not so much, but I'm going to try to squeeze that in, okay? So 1.96, and it's going to be times the standard error. Now, you know what I'm going to do? Because I'm running out of room myself, I'm going to put SE for standard error because, again, my screen is limited. What is the standard error? Well, I'm going to put that over here so that we can have everything where it belongs. The standard error is the square root of the two samples proportions. So we have 0.65 times 0.35, p hat q hat, over 80, the n, and 0.73, and I'm going to abbreviate this, times 0.26 repeating over its sample size 75. So if you do the math, you find that that standard error is going to be something I didn't put on paper. Oh, wait, there it is, 0.0738. I did it, 0.0738. All right, so again, I'm showing you the bits and pieces of the equation. We're doing it just fine. Standard error, 0.0738. Up here, what's 0.65 minus 0.73 repeating? Well, that's negative 0.0833. Plus or minus 1.96 times the standard error of 0.0738 is 0.1446. All right, well, when I subtract and add, I get negative 0.2279 to positive 0.0613. All right, going to pause here and verify that on our calculator. So we go to our handy calculator, and what function tells us the two proportion z interval? Well, not surprisingly, it's 2 prop z interval. Where do we find it? Stat, tests, and 2 prop z interval is down at the B option, 2 prop z int. Okay, well, x1 was 52, and 1 was 80. x2 is 55, and 2 is 75. I want a 95% confidence interval. Please make sure that your inputs look like this. And we calculate, and we find, not surprisingly, negative 0.228, rounded to 3 decimals, to positive 0.06137. Okay, I think we're good. We are off by no more than 1/10,000th, and I'm happy with that. What does it mean? Well, here's the sentence you would write. We are 95% confident that the true proportional difference between Connecticut State and New York State income earners who make at least $85,000 a year is between negative 0.2279 and positive 0.0613. What's contained within that interval? The number 0. Starts at negative, ends up positive. When 0 is contained inside the interval, it tells us very specifically that there's probably no difference between the two, or at least there's no statistically significant difference between the two. And that's what we're going to also verify with the hypothesis test right now. So bear with me because I'm going to erase this. and do a quick version of the hypothesis test. Hopefully you've written this down, because I'm no longer going to have it up here. All right, so how do we do the hypothesis test? Well, once again, using the same data, having confirmed the conditions already, I'm just going to start in with my statements. All right. Again, I already wrote them and I erased them naturally, but the null was that the proportional difference is 0. Got a shaky board. And the alternate is that the proportional difference was not 0. Okay. I know already that in order to find out the area in the tails, to find the p-value, to make a comparison, I need to find my z-score. The equation is the difference in the z-score is equal to, we got the numerator 0.65 minus 0.7333 over the square root of, and this is where that p hat combined, q hat combined comes in. We already found them. They were 0.6903 times 0.3097, and that's over the first sample size of 80, plus the exact same numerator, 0.6903 times 0.3097, over the second denominator, 75. And that tells me that my z-score for the difference is actually negative 1.1209. All right, negative 1.1209. We know it's a two-tailed test, so we have to make the negative and the positive. So let's just draw a quick sketch. We got 0 in the middle. We got the negative 1.1209 here, the positive 1.1209 there. And with a two-tailed test, we shade both tails. Okay, how do I find the z-score? I'm sorry, how do I find the area? Using the z-score. Normal CDF. Why are we allowed to use normal CDF? Because we verified the conditions. So from negative infinity to a negative 1.1209 bound, with 0 and 1 as our mean and standard deviation, the area there is 0.1312. Now, listen, that's already more than 5%. We have to actually keep going, but we already know that the area in just one tail is more than 5%. We have to double it because it's a two-tailed test, so we get 0.2614. That's way over any alpha, but certainly more than the 5% alpha that I had suggested we start with. All right, what do you do when your p-value is more than alpha? You fail to reject the null. We cannot reject the null that there is no statistically significant difference between the two states' proportions of income earners over $85,000. By not rejecting the null that there's no difference, we're basically saying there's no difference between the two states, which is what we also decided based on the confidence interval. Okay, good. Now, how do we double check it? I told you I'd show you. So again, here it is. Not surprisingly, 2 prop z test. So under stat and tests is our 2 prop z test. It's the 6th option down. And it already populates the right data because it knew from our previous inquiry what our x and n 1s and 2s are. So it already popped them in for me. So 52 and 80, 55 and 75. Change the alternates symbol to does not equal. Make sure it's highlighting does not equal. And calculate or draw. If I calculate it, again, it tells me everything I already know. All right, it gives me everything that I found out on the board. The z-score for the difference, negative 1.1213-ish. It gives me the p-value right below that, 0.26213. It's going a little bit further because it didn't round anything. It tells me the individual p-hats, and the p-hat combined is just p-hat equals, and it says 0.6903225806. It tells you everything you need to know. It's right there. All right. Multiple choice questions, just use the calculator. But open-ended, you got to show your work. So here's what we're going to do for homework today. I'm going to give you guys an attachment to in the classroom. It's going to be the 10.1a worksheet. I'm also giving you the answers on the page following it. So do the work first, then check your answers. If you have any questions, of course, feel free to ask me. Okay, hopefully this is clear. If you have any issues, always send an email. And can I put my pajamas back on now?
Yes.
Thank you.